Hi, this is John Isles and welcome to Geometer's Paradise. Today we're going to be talking about Unit 5, Lesson 4, using the converse parallel transversal theorems. We just have one goal today, and that is that you are going to be able to build short proofs that link together angles and transversal relationships to prove that lines are parallel. We begin with the theorems. These are the regular transversal theorems. Notice how we have the two lines being parallel and cut by a transversal, and we end with congruence. We're going to do the converse of these, and remember that converse means that we're going to switch the hypothesis and the conclusion. So this part is going to trade places with this part, and we're going to make the converse. And here they are. If two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. If two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. Notice how each of these ends with the lines are parallel. The lines are parallel. And all of those angle statements have moved to the hypothesis of the statement. Also in the hypothesis of the statement is the cut by a transversal part, and that never moved. This is because we had the and condition in the hypothesis, and our converse only switched the conclusion with one of the two parts of the conjunction. All right, so let's look at an application. Here we have four angle relationships, and what we want to do is identify these angles, like here's angle 4 and angle 5. And angle 4 and angle 5 are alternate interior angles. Okay? Now we have a theorem that says when alternate interior angles are congruent, the lines are parallel. So here they're congruent. All right, that means we have parallel lines. So the lines that form these alternate interior angles are T, A, and B. T is the transversal because it forms part of each of the two angles, which means A and B are parallel. So we say A is parallel to B by the converse alternate interior angles theorem. All right, now let's look at 1 and 9. Okay, so 1 is over here, 9 is over here. These two angles have a relationship. They are corresponding angles. A is their transversal, so T and S are the parallel lines. So T is parallel to S by the converse corresponding angles theorem. Then we have 8 plus 15. We have 8 and 15, and these angles are consecutive interior angles, the top secret ones, CIA. And B is their transversal, so T and S are parallel. T is parallel to S by the converse consecutive interior angles theorem. And finally, angle 9 gets connected to angle 16. All right, these are alternate exterior angles. So this means that A is going to be parallel to B because S is their transversal by the converse alternate exterior angles theorem. I was hoping I could move that little recycle bin, but all right. Okay, let's write some proofs. So these are a little different from the proofs that we wrote before. In Unit 5.3, these proofs were, the statement was let A be parallel to B and T be parallel to S as the givens, and show that angle 1 is congruent to angle 16. This is opposite. We're trying to show that two lines are parallel. So let's think backwards for a moment. If I want two lines to be parallel, A and B, my converse theorems say that I have to have angles that are either corresponding alternate interior, alternate exterior, so that's corresponding alternate interior, alternate exterior, or consecutive interior angles. So 1 doesn't have a match on A and B, but 9 does. 9 and 16 match up, and they're alternate exterior angles. So what this does for me is it allows me to kind of work backwards from the bottom to the top on my proof. Wow, that was a terrible line. Okay, so I know what my last statement is. My last statement is that A is going to be parallel to B. And right before that, I'm going to say something along the lines of angle 9 is congruent to angle 16. And the reason why this is important is that this statement allows me to make the claim that the lines are parallel by the converse alternate exterior angles theorem. But the question is, how can I make these two things congruent? Because they're not. So I go back up into my proof and I say, all right, what do I know? I know that 1 and 16 are congruent. 1 is already connected to 16 because it's given that they're congruent. And then 1 and 9 are corresponding angles. And T is parallel to S. That means 1 is congruent to 9. So I can build the connection through these blue lines. I can say that angle 1 is congruent to angle 16 because it's given. And then I can say that angle 1 is congruent to angle 9 because of the corresponding angles theorem. Now that's not the converse, it's just the regular corresponding angles theorem because T is parallel to S. All right, so this theorem is activated because T is parallel to S. Then we have a connection that we can make from the ones that lets us say that angle 9 is congruent to angle 16 by the transitive property. And there it is. You have a given, okay, you have a given, you have a parallel transversal theorem, you've got the transitive property, and then you have a converse parallel transversals theorem. That should be TT. Okay, this is the pattern every time. Given, parallel transversal, transitive, converse parallel transversal. All right? So just keep that in mind as you're doing your problems. Okay. Next proof. Again, let's start by working backwards. We want to know that T is parallel to S. So that's T and S. And the angles that are associated with that are 4 and 12. Notice that 4 and 12 are corresponding angles. So the end of my proof is going to be something like angle 4 is congruent to angle 12, and then T is parallel to S. But the beginning of my proof is going to be a little more subtle. All right, we need to, so let's write the ending here. T is parallel to S, okay, and before that we need to say that angle 4 is congruent to angle 12. And that's going to give us T parallel to S by the converse CAT theorem, converse corresponding angles theorem. So how can we make this happen? Well, we already know that 5 is congruent to 12. So we have this connection because it's given. Okay? And then 5 gets connected to 4 by the alternate interior angles theorem because A and B are parallel lines. So angle 5 is congruent to angle 12, given. Angle 5 is congruent to angle 4. Alternate interior angles theorem because A is parallel to B. All right, and then of course we have our connection here through the 5s, which means that this is congruent by the transitive property. All right, so we work backwards to figure out how to set up our proof. Okay, same deal. Now we want to know that A is parallel to B. So A and B need to be parallel. And the angles that are associated with that are 2 and 3. These angles are consecutive interior angles. So that means that they have to sum to 180. These are not equal. These have to sum to 180. So the end of my proof is going to look like this. I need to have A is parallel to B. And then the line before that needs to be angle 2 plus angle 3 equals 180. So I need to create that. And that will allow me to use the converse consecutive interior angles theorem to finish the proof. So how can I set this up? Well, first of all, I need something equal to 180. And I don't have it here. All I have here is congruence. I can connect 1 to 3. But T is parallel to S, and that means these angles, which are also CIA, are equal to 180. So angle 1 plus angle 2 is equal to 180. Hang on here. That doesn't look very plusy. There we go. All right, and this is the CIAT theorem, consecutive interior angles theorem. And then we can say that angle 1 is congruent to angle 3 because of the given. All right, so look here. We can make a quick substitution. All right, and that's going to give us this by substitution. Last proof. All right. Now we want to show again that A is parallel to B. Whoops. So this is what we want, A and B to be parallel. I do not want to do it in yellow though. I want A and B to be parallel. So the angles associated with that are 11 and 13. Notice how they are consecutive interior angles. They have to sum to 180. So at the end of my proof looks like this. A is parallel to B. Why? Well, because angle 11 plus angle 13 needs to be equal to 180. And that allows me to use the converse consecutive interior angles theorem. Okay, so let's begin. We need to build our connections. All right. We already know that 5 plus 11 equals 180. These two angles are connected through the given. And then T is parallel to S, which means these two angles are connected by corresponding angles. So angle 5 plus angle 11 is equal to 180. Given. Angle 5 is congruent to angle 13. Corresponding angles theorem because T is parallel to S. And then we can make a substitution. So here it is. We're going to replace 5 with 13. All right, and that gets us this statement by substitution. There you have it. Okay, your homework assignment is basically to go through and do these exact kind of problems. So good luck, and I will see you in class tomorrow.